Hey everyone, welcome to another session of Serazzle Dazzle Physics. In today's session, we're going to be talking about heat transfer, guys. So put down today's title, it's going to be heat transfer. Right, so we'll start with the following scenarios. So we've got a scenario A here and scenario B over here. A is in the winter and B is in the summer. As you can see in the winter, the temperature is 5 degrees Celsius. Okay, so the temperature is 5 degrees Celsius over here. And in the summer, we know the temperature is 30 degrees Celsius. I've just given you those values here. We have a cup of tea in both of them. Let's say your mom makes you a cup of tea. It's 25 degrees Celsius in this one. Yeah, not that warm, yeah. And it's also 25 degrees Celsius in this one. Okay, so that's the starting point. The question is the following. What is going to happen to the temperature of the tea as time goes on for both scenarios? So for both scenarios, what is going to happen to the temperature of the tea? Right, so hopefully you can identify that there's going to be a transfer of heat from one place to the other. So the key thing to note is that heat flow is always from hot to cold. So as you can see, heat flow is always from hot to cold. That's a key thing, guys. So the heat transfer is always from hot to cold. So if you look at the first scenario, we've got 25 degrees Celsius as a T. It's 5 degrees outside. So what's going to happen is there's going to be heat loss from the T to the surroundings, because it's going from the hot 25 degrees to the cold 25. So there will be some heat loss from the tea in the winter. So that will actually cause the temperature of the tea to drop down. So let's put that down here. So temperature of tea decreases. Wonderful. And that's what's going to happen for scenario A. What about scenario B? What's going to happen now? So now look, in the summer, the temperature outside is greater than the temperature of the tea. And you know that heat transfer is always from hot to cold. So yes, this time the heat is going to go into the cup of tea over here. There we go. And obviously the heat is now going into the cup of tea. Therefore the temperature of the tea will increase. So the temperature of the tea will increase. Happy with this? So the key thing to note is that in that scenario, I'm trying to explain to you that heat transfer is always from hot to cold, guys. So it's always from the hot to the cold. In the winter, the heat goes from the tea to the surroundings. The reason why the tea is hotter than the surroundings. In the summer, the heat transfers from the outside into the tea. Why? The outside is hotter than the tea in this case here. Right, so let's test our understanding with the following problem. What is wrong with the following statement? Shut the door, you are letting the cold in. Shut the door, you are letting the cold in. What is wrong with this statement? Well, hopefully we can remember from what we just learnt that heat is only going to go from hot to cold. Hot to cold. So look, in this scenario, it doesn't really make sense. That means that if you leave the door open, cold comes in. No, that's not going to happen here. So the cold is not actually going into your house. What's happening is your house is losing heat. So if I was to swap out the diagram, guys, it shouldn't be the cold going in. What I should be drawing is that the heat should be lost from here. So look, guys, the heat is being lost from your house. So the heat is being lost from your house because it's going from hot to cold. So next time someone says to you, shut the door, you are letting the cold in, you can correct them and say, actually, I am letting the heat out of the house as the heat transfer is from hot to cold. Yep, so now you can use this next time someone says to you, don't leave the door open because you're letting the cold in. You can now correct them with a bit of physics saying that it's not the cold coming in, it's the heat being lost from the house. Okay, right. What about the temperature difference now and the rate of heat transfer? So what about the following? Alright, so now let's look at how the temperature difference between two objects affects the rate at which heat is transferred between them. So how does the temperature difference between two objects affect the rate at which heat is transferred between them? So look at this scenario here. So we've got two scenarios in winter and summer. In the winter, the temperature outside is 5 degrees Celsius. 5 degrees Celsius. In the summer, we know that the temperature is 40 degrees Celsius. Fine. Let's say the cup of tea in both of them is going to be 60 degrees Celsius. So 60 degrees Celsius, the cup of tea, and it's 60 degrees Celsius over here. First of all, we know that heat will be lost from hot to cold. So yes, this one will lose heat to the surroundings. Okay? And so will the other one. Why? Because it's hotter than the surroundings. But which one will lose heat at a faster rate? Well, it's all about the temperature difference between them. So look at the temperature difference between them. So in the summer, let's work out the temperature difference. So the difference in temperature is going to be 60 degrees Celsius minus 40 degrees Celsius. It's going to be 20 degrees Celsius is the temperature difference. So let's put that down as the change in temperature is equal to 60 degrees minus 40 degrees. This symbol here, theta, stands for the temperature, guys. Okay, so it's going to be 20 degrees Celsius is the temperature difference. What about in the winter? So in the winter, we know that the temperature difference now, the change in temperature is going to be 60 degrees minus 5 degrees. Therefore, it's going to be 55 degrees Celsius. Okay, so hopefully we have the understanding that in the winter, it will lose heat at a rapid rate. The reason why is because there is a larger temperature difference. Because look, the 55 here, the temperature difference, is much larger than the 20 here. So we can conclude that the greater the temperature difference, the faster the rate of heat transfer. Let's put that down. Yep, so the greater the temperature difference, the greater the rate of heat transfer. That should make sense, guys. So look, think about it. Let's say your mum makes you a cup of tea in the winter compared to the summer. Obviously, in the winter, it would cool down rapidly because there's a greater temperature difference between the cup of tea and the surroundings. That makes sense, guys, yeah? Hopefully we've seen that scenario. Okay, let's have a quick recap on everything we've covered so far today. So at the top, we said the title is heat transfer, okay? And then we gave you the following scenario: have a cup of tea in the winter and the summer. We identified that heat transfer is always from hot to cold. So in the first scenario, it goes from the cup of tea to the surroundings. Why? The surroundings is at a lower temperature than the tea. Then in the summer, the heat transfer is obviously going to go into the cup of tea. Why? Because the temperature outside is greater than the temperature of the tea. And then we did a test your understanding with this simple scenario. It's going to be, what's wrong with the following statement? Shut the door, you are letting the cold in. Well, the reason why that's wrong is because you're not letting the cold in, you're letting the heat out. And last of all, we talked about how the rate of heat transfer is related to the temperature difference. So we can clearly see that the temperature difference influences the rate of heat transfer. The greater the temperature difference between two bodies, the greater the rate of heat transfer. As you can see, in the winter, the cup of tea cools down much faster than the summer. The reason why, there is a greater temperature difference. And that's the reason why. Wonderful, and that's it for another session of Serazzle Dazzle Physics. Make sure you like and subscribe to keep my channel going so we can educate as many kids as possible. And don't worry, in the next videos, guys, I'll be talking about conduction, convection and radiation to develop your understanding even further. Ciao, ciao, and goodbye.